We hope you've had fun with the Wave Characteristics Relationships Lab. It's a long title, but a great investigation. This video takes us through the first 4 days of the lab and sets us up for the final day. The wave on a string application is very well known to you now. We've used it in the oscillating mode. We did not put an ending here, so nothing's reflecting back and the waves are just traveling through here. And we've measured characteristics. That's the characteristics in the wave relationships lab. The characteristics, of course, that we've been measuring and then looking at are speed, frequency, period, wavelength, and amplitude. Now these are all real different things except for these two right here. Frequency and period are two different ways to express effectively the same thing. So generally, if something has a relationship with frequency, it'll demonstrate a similar but kind of reverse relationship with period. So period and frequency are kind of two ways to measure the same thing. So what's the relationships part of the characteristics lab? This kind of shows what we wanted to investigate, which was, now that we can measure all these things, can we find if there's relationships between them? And that's what you've been doing. So this kind of shows if we plotted them all out, we might put all of these characteristics on the y-axis, put all of these characteristics on the x, and then see if there's a relationship. I guess we could have done this just in one step, but we did this sort of a day at a time. How did we do that? How did we generate that data? Well, on the first day of the lab, this was day 1, you received the assignment of some wave 1 and some wave 2. Wave 1 gave some combination of amplitude and frequency. Wave 2 gave some combination of amplitude and frequency. And then you went through, and based off the practice you did before that, you were able to calculate each of these characteristics, and then you reported them. Now, 2 data points really is not enough. And the way we did that is to generate lots of different lots of different waves randomly. So while somebody might have gotten this combination of amplitude and frequency for wave 1, these were other combinations of amplitude and frequency for wave 1. And somebody might have gotten this combination for wave 2, but these other combinations of those two were also assigned. So we set the amplitude and frequency to whatever was assigned, but in this way we really got like 13 data points, which was enough to make good graphs that show the relationships. There is one constant here though, and that is everybody was always instructed to set the tension to low. And we'll come back and talk about that, but that does have an effect on some things. So here is every combination of frequency and amplitude that was assigned, and then you all went through and filled out the rest of this. So we had this set of data and it allowed us to plot any column versus any column. Now, we did eliminate some data if there was bad mistakes. And where did people make mistakes? The worst mistakes, other than not converting this into meters, the worst mistake was in here, and incorrectly, once you paused it, incorrectly counting the number of cycles. The reason that's important is cycles was one of the measurements to calculate both period and frequency. It was one of the measurements used to calculate wavelength, and maybe you got it right up here, but if you incorrectly calculated number of cycles here and got period and frequency wrong, that means you incorrectly calculated your speed here. So a mistake on the number of cycles and visually looking at it and counting the number of cycles was a big one. So we had all the data and we just kind of set out to fill that table that I showed. So in day 2, just to make sure everybody had the graphing program down, because we're going to use it really on all the days. You guys looked at period and frequency. Well, how does period and frequency look? So effectively we said that's the y-axis and that's the x-axis, and let's plot the two. And this is what you found. Not a real surprising result, but it does confirm what we know about period and frequency, and that is that period and frequency are defined as the inverse of each other. If we would have plotted frequency versus period, we would have gotten the same exact thing, right? Because you can just algebraically switch the period and frequency there. But this math model here is showing what we know about period and frequency. So it is a good sign that we were able to use the data to get that result. And as we go through this, I'm just going to compile our findings here and show the summary of the graphs and anything we learned from it. On day 3, we said, what does the amplitude versus some other things look like? So we plotted amplitude versus frequency, period, and wavelength. In other words, if this is amplitude, y, then how does it look against this independent variable, this independent variable, and this independent variable? And these were 3 different graphs. And this is what you found. Now, I said earlier, period and frequency are basically measures of the same thing. So the fact that we would have gotten a shape like this for frequency means it's not surprising that we would have gotten a shape like this for period. Wavelength is a different thing, and we got that same idea here. So a lot of people were, just accurate about how they explained this, and they said that it just appears that there's no relationship between the two. I'm going to switch over to the wave machine and show why would there be no relationship between amplitude and frequency, and then certainly amplitude and wavelength. So here's the wave machine just running through here. And the reason there's really no relationship between amplitude and frequency is they're both sort of independent variables. So as we make these waves, we can adjust amplitude up or down, we can adjust frequency up or down, and we can do that independently of each other. So we can say, let's go really low amplitude, really low frequency, and we produce that graph. What if we went really high amplitude, really low frequency? Aha. We can do really low amplitude, really high frequency. Cute little wave. Or we can do really high amplitude, really high frequency. And that's kind of dizzying. But the point here is that amplitude and frequency, if you are, I gotta pause that. Although there's a really cool pattern going on. Do you see that? That's neat. If you are the person oscillating this, like if you were the person hanging on to the end of this creating waves, you could adjust your hands to be high or low amplitude, you could adjust your hand to be high or low frequency, and they're independent of each other. The other thing was wavelength though, and it does kind of show us, we know a little bit about wavelength being the distance between these crests. So this is the wavelength right here. And it turns out amplitude appears to have no effect on that. Now, wavelength is going to be a big idea as we move into day 5 of the lab. But if there is a thing that affects wavelength or has some control over the wavelength, this graph is showing us, the graph results is showing us that it's not amplitude. And that just shows that result right here. So populating our table, filled out 3 more of these intersecting cells. And the big idea there is amplitude is not related to any other characteristic. In the case of frequency and period, it's because amplitude and frequency and period are both seen as independent variables or things that the oscillator can control. In the case of wavelength, if something does affect wavelength, and we'll ultimately find that it does, it's not amplitude. You can't change the wavelength by changing the amplitude. Day 4 of the lab, we looked at velocity versus everything else. In other words, if speed is the dependent variable, let's plot it against all 4 independent variables, if you will. And here's what we got. I think it's pretty obvious that speed is not changed by anything, but it's a different type of no relationship. In the amplitude graphs, no relationship meant that it's kind of a scatter plot. In this one, no relationship shows that even though we change these things, this doesn't change. So I would call this no relationship but constant. Frequency can go up or down, speed doesn't change. I can change amplitude up or down, speed doesn't change. Now, these two are sort of counterintuitive when you talk to people that don't know much about waves. What do I mean by that? Well, if we have a medium through which we're going to send a wave, and you tell somebody you want them to send the wave through the medium faster, they will attempt a couple of things in order to do that. So they might say, all right, in order to send the wave faster, I'm going to send a huge amplitude. I'm really going to wail on it here. And so they'll say, I'm going really big waves. And it doesn't work. It doesn't send it any faster. Another thing they might do is say, well, I'm going to shake it back and forth very rapidly. And in doing so, I'm going to send the wave faster. But it doesn't send the wave any faster. So a really big idea here is that if we have the same string, both of these two do not change the speed. The speed is constant as long as it's in the same medium. Now that's back to where we started when I showed all the data points. All of you were assigned the same medium, and that means low tension. If you change the medium, you can change the speed. So if I change all of a sudden, if I increase the tension in the string without changing either of these things, you'll notice the waves start moving faster. If I go even faster, aha! So at the low speed, if I were to time this and restart, I could time how long it would take to get to the end. Right? About that long. If I go to medium speed, for medium tension, watching this crest, oh yeah, quite a bit shorter. If I go to high tension, even less time. So the properties of the medium are what affect the speed. And when I did change something about the medium, I can in fact change the speed. But as long as the tension is low, either of these things did not affect the speed. So then populating our table here, speed or velocity versus all the other things is no relationship but constant. It is not okay, though, to say that speed is always constant. Speed is constant as long as the medium doesn't change. It is the properties of the medium that control the speed at which the disturbance travels through it. And you cannot change that speed by changing something about the oscillating source, like the frequency or the amplitude. You can't make a wave go faster through period and amplitude. You can only make it go faster by changing properties of the medium. Now in day 5, we're going to have you investigate the effect of wavelength versus frequency and period. We know that if wavelength is affected by something, it is not amplitude, because we've already done that wavelength versus amplitude graph. So the two that are left are frequency and period. So I hope you enjoy that, and we will wrap that up in a day or two here. Thanks a lot.